Welcome everyone to our journey into the world of data science. In today's digital age, we often hear the phrase data is the new oil. But just like crude oil, raw data is unrefined and needs processing to become valuable. Data science acts as the engine that transforms this raw material into fuel for innovation, powering everything from business decisions to technological breakthroughs. As we begin, let's explore what makes data science so essential in our modern era, setting the stage for deeper understanding in the scenes ahead. Data science is a multidisciplinary field that blends inference, algorithm development, and technology to solve complex problems. It's not just about crunching numbers or coding, it's about extracting actionable insights that drive decision-making. By combining skills from mathematics, computer science, and domain expertise, data scientists are able to turn vast amounts of information into meaningful results. This definition sets the foundation for everything we'll discuss, showing how data science is both broad and deeply impactful. The heart of data science lies a powerful triad: mathematics and statistics, computer science, often referred to as hacking skills, and domain knowledge. Each component is crucial. Mathematics provides the tools for inference and analysis, computer science enables us to process and manipulate data efficiently, and domain knowledge ensures that our solutions are relevant and practical. Together, these pillars support the entire data science process, making it possible to tackle real-world challenges with confidence. The ultimate goal of data science is to extract actionable insights from data. These insights drive decision-making, whether in business, healthcare, or technology. By analyzing patterns, trends, and relationships, data scientists help organizations make informed choices that lead to innovation and growth. This process transforms raw data into a valuable resource, fueling progress across industries and shaping the future. Professional data science follows a structured life cycle, often referred to as CRISP-DM. Unlike beginners who jump straight to building AI models, experts understand that most of their time is spent preparing and cleaning data. This cycle ensures that every step, from understanding the business problem to evaluating the final model, is handled with care. Let's break down each stage to see how they contribute to successful data science projects. First step in the data science lifecycle is business understanding. This means asking the right questions and identifying the core problem to solve. Without a clear understanding of the business context, even the most advanced models can miss the mark. Data scientists work closely with stakeholders to define objectives, ensuring that their efforts align with organizational goals and deliver meaningful results. Once the problem is defined, the next step is data acquisition. Data can come from various sources, such as SQL databases, APIs, or cloud storage. Gathering the right data is essential for building accurate models. Data scientists must ensure that the data is relevant, reliable, and sufficient to address the business problem. This stage lays the groundwork for all subsequent analysis and modeling. Data wrangling is where data scientists spend most of their time. This involves handling missing values, outliers, and inconsistencies in the data. Cleaning and organizing data is crucial because poor quality data leads to unreliable results. By carefully preparing the data scientists ensure that their models are built on a solid foundation, minimizing errors and maximizing accuracy. Exploratory data analysis, or EDA, is the stage where data scientists explore the data to find patterns, trends, and relationships. Visualization tools help make sense of complex datasets, revealing insights that might otherwise go unnoticed. EDA is a critical step for understanding the data's structure and guiding the modeling process, ensuring that the right features are selected for analysis. Modeling is where machine learning algorithms are applied to the data. This stage involves selecting the right model, training it, and tuning its parameters to achieve the best performance. Data scientists use their expertise to choose algorithms that fit the problem and data characteristics, aiming for models that are both accurate and interpretable. Valuation is the process of testing the model's accuracy and real-world utility. Data scientists compare model predictions against actual outcomes, using metrics like accuracy, precision, and recall. The goal is to ensure that the model not only performs well on test data, but also delivers value in practical applications. This step is essential for validating the effectiveness of the solution. Artificial intelligence, or AI, is the broad umbrella under which machine learning and deep learning reside. AI encompasses systems that can perform tasks requiring human intelligence, such as reasoning, learning, and problem-solving. Understanding this hierarchy helps clarify how different technologies fit together and what makes each unique. Machine learning is a subset of AI where computers learn patterns from data. Instead of being explicitly programmed, these systems improve their performance by analyzing examples and adjusting their algorithms. Machine learning powers many modern applications, from recommendation systems to fraud detection, making it a cornerstone of data science. Deep learning takes machine learning a step further by using multi-layered neural networks. These networks can learn complex representations and are behind breakthroughs like ChatGPT and self-driving cars. Deep learning excels at tasks such as image recognition, natural language processing, and autonomous systems, making it one of the most exciting areas in data science today. Generative AI represents a shift from predicting data to creating it. These models can generate text, images, and even music, opening new possibilities for creativity and automation. Generative AI is transforming industries by enabling machines to produce content that was once the exclusive domain of humans. ML ops, or machine learning operations, is the practice of scaling and maintaining models in production. It involves deploying models, monitoring their performance, and updating them as needed. ML ops ensures that machine learning solutions remain effective and reliable over time, bridging the gap between development and real-world use. Small language models, or SLMs, are efficient AI systems designed for specific tasks. Unlike large models, SLMs focus on targeted applications, making them faster and more resource-friendly. These models are ideal for scenarios where speed and efficiency are critical, such as customer support or real-time translation. Ethics is a fundamental concern in data science. Bias in data can lead to unfair outcomes, affecting individuals and communities. Data scientists are responsible for ensuring transparency and fairness in their work, making ethical considerations a core part of every project. By addressing ethical challenges, we build trust and create solutions that benefit everyone. Privacy is a key issue in data science, especially with regulations like GDPR. Protecting personal data is not just a legal requirement, but a moral obligation. Data scientists must implement safeguards to ensure that sensitive information is handled responsibly, respecting the rights of individuals and maintaining public trust. Explainability refers to understanding why a model makes certain decisions. It's important for data scientists to be able to explain their models to stakeholders, ensuring transparency and accountability. Explainable models help build confidence in AI systems and allow users to make informed decisions based on the model's outputs. Bias mitigation is about ensuring fair outcomes for all demographics. Data scientists must identify and address biases in their data and models, striving for solutions that are equitable and just. This process involves careful analysis and ongoing monitoring, making fairness a continuous priority in data science. Data science is more than a technical skill, it's a critical mindset. Data scientists must approach problems with curiosity, skepticism, and a willingness to learn. This mindset drives innovation and ensures that solutions are both effective and ethical. By cultivating a critical approach, data scientists can navigate complex challenges and deliver meaningful results. Data science plays a pivotal role in business, helping organizations make data-driven decisions. From optimizing marketing strategies to improving customer experiences, data science enables companies to stay competitive and adapt to changing markets. The insights gained from data analysis drive growth and innovation across industries. In healthcare, data science is revolutionizing patient care and medical research. By analyzing patient data, predicting outcomes, and personalizing treatments, data scientists are improving health and saving lives. The integration of data science in healthcare is leading to more accurate diagnoses and better resource allocation. Technology and innovation are at the core of data science. By leveraging advanced tools and techniques, data scientists are able to solve problems that were once thought impossible. The rapid evolution of technology is expanding the possibilities for data science, enabling new applications and discoveries every day. Education is another area where data science is making a difference. By analyzing student performance and tailoring educational content, data scientists help educators create more effective learning environments. Data-driven insights are shaping the future of education, making it more personalized and impactful. In finance, data science is used to assess risk, detect fraud, and optimize investments. By analyzing market trends and customer behavior, data scientists provide valuable insights that help financial institutions make smarter decisions. The ability to predict and manage risk is a key advantage in the fast-paced world of finance. Retail and e-commerce businesses rely on data science to understand customer preferences, optimize pricing, and manage inventory. By analyzing sales data and market trends, data scientists help retailers stay ahead of the competition and deliver better customer experiences. Data science is transforming transportation and logistics by optimizing routes, predicting demand, and improving efficiency. By analyzing traffic patterns and shipment data, data scientists help companies reduce costs and deliver goods faster, making supply chains more resilient and responsive. Data science is playing a crucial role in environmental protection. By analyzing climate data and monitoring pollution, data scientists help organizations develop sustainable practices and reduce their ecological footprint. The insights gained from environmental data are guiding efforts to preserve our planet for future generations. Governments use data science to inform policy decisions, improve public services, and enhance transparency. By analyzing social and economic data, policymakers can make evidence-based decisions that benefit society. Data science is helping governments become more efficient and responsive to citizens' needs. In sports, data science is used to analyze player performance, optimize training, and develop winning strategies. By collecting and interpreting data from games and practices, coaches and athletes gain a competitive edge, making data science an integral part of modern sports management. Media and entertainment companies use data science to personalize content, predict trends, and enhance user engagement. By analyzing viewing habits and preferences, data scientists help create more enjoyable and relevant experiences for audiences worldwide. Social media platforms rely on data science to analyze user behavior, detect trends, and improve content recommendations. By processing vast amounts of data, data scientists help platforms stay relevant and engaging, connecting people across the globe. Data science faces many challenges, including data quality, scalability, and ethical concerns. Overcoming these obstacles requires technical expertise, creativity, and a commitment to continuous improvement. By addressing challenges head-on, data scientists ensure that their work remains impactful and trustworthy. The future of data science is bright, with new technologies and applications emerging every day. Advances in AI, machine learning, and big data are expanding the possibilities for innovation. Staying informed about future trends helps data scientists remain at the forefront of their field and drive progress. Collaboration is essential in data science. Data scientists work with engineers, analysts, and domain experts to solve complex problems. Effective teamwork leads to better solutions and fosters a culture of innovation. By sharing knowledge and skills, teams can achieve more together than alone. Continuous learning is vital for data scientists. The field evolves rapidly, with new tools and techniques emerging all the time. Staying up to date with the latest developments ensures that data scientists remain effective and competitive, ready to tackle new challenges as they arise. Strong communication skills are essential for data scientists. Explaining complex concepts to stakeholders and presenting findings clearly helps ensure that insights are understood and acted upon. Effective communication bridges the gap between technical and non-technical audiences, making data science accessible to all. Problem-solving approach is at the core of data science. Data scientists use analytical thinking and creativity to tackle challenges, developing innovative solutions that address real-world needs. This approach ensures that data science remains relevant and impactful, driving progress across industries. Data scientists use a variety of tools and technologies, from programming languages like Python and R to platforms for cloud computing and data visualization. Mastering these tools is essential for effective data analysis and modeling, enabling data scientists to handle complex tasks with ease. Data visualization is a powerful way to communicate insights. By presenting data in charts, graphs, and interactive dashboards, data scientists make complex information accessible and understandable. Visualization helps stakeholders grasp key findings quickly, supporting informed decision-making. Big data presents unique challenges, including storage, processing, and analysis. Data scientists must develop strategies to handle large datasets efficiently, ensuring that insights are accurate and timely. Overcoming big data challenges is essential for unlocking the full potential of data science. Responsible data use is a cornerstone of data science. Data scientists must respect privacy, ensure security, and act ethically in all their work. By following best practices and adhering to regulations, they build trust and create solutions that are safe and reliable. As we wrap up, remember that data science is more than just a technical discipline. It's a mindset that combines curiosity, ethics, and innovation. By mastering the essentials and embracing continuous learning, you can unlock the full potential of data science and drive meaningful change in your field. Thank you for joining this introduction to Data Science Essentials.